So today we're going through 4i. We're solving trigonometric equations in quadratic lines. Now you've seen a little bit of this already. I did touch on it a little bit earlier. So we'll just go into it in a little bit more detail. There's only 4 questions. Then you'll have a bit of opportunity to complete some of the worksheet questions. So hopefully you sort of got up to 25. We'll come and see how we're doing, where we got stuck, maybe issues we had, and go through some common questions together. But that'll be one that we keep working on at home. In tomorrow's lesson, I'll bring along some practice tests as we finish the unit. And if you're looking at set there, you'll see that our test is scheduled for this time next week. So that's the plan at this stage. Standard test, A4 sheet of paper, graphics calculator. Not that you really need it for this one, but. Okay, so let's get into here. We're going to solve these equations by factorising and then applying the null factor law. So we're looking for a common term here. We're going to say cos x is common, and that's going to leave us in brackets with cos of x plus 1. If you were to expand that, you're going to get the top here. Then we'll apply the null factor law. Okay, you hear me saying that a fair bit. So the null factor law is if a times b equals 0, then a is 0 or b is 0. That's the only possible solution. Alright? You can't have, there's no two non-zero numbers that will multiply together to give you 0. Okay, so we've got cos x times cos x plus 1. So let's apply the null factor law. Cos x is 1, cos x is 0, or cos x plus 1 is 0. Now for this solution, we can look at our unit circle and we're going, where is cos of x 0? So the solutions here are going to be pi on 2 and 3 pi on 2. Alright, so like we've been doing this heaps now, so I'll tell you like how I'm thinking about that. I'm going x, cos is the x coordinate, the x coordinate is 0 here and here, and I know that's pi on 2 and 3 pi on 2. That's how I'm generating that solution. Over here we're going to get cos of x is minus 1. Okay, again cos is the x coordinate, minus 1 is here, that's at pi. Okay, and we're only asked to answer between 0 and 2 pi, so we've listed all the possible solutions there. Okay, we have sine squared x take cosec squared of x. So let's write that without the reciprocal ratio. So that's 1 on sine squared of x. And that says equals 0, doesn't it? Is that correct? Say equals 0? Yes. Okay, so then what we're going to do is we'll multiply by this denominator so that we can perform that operation. So what we're going to have then, I'm multiplying this one by sine squared x on sine squared x. I'm multiplying the whole side by it. And same as this one, sine squared x on sine squared x. So you're not changing the value of, because that's 1 and that's 1, so we're not doing anything absurd. We can do it to both sides. And so here we're going to get sine to the 4x, take 1. And over here we're going to have 0. Yeah, sorry, we don't need to multiply even by 1. We can multiply by the same thing as long as we do it to both sides. And that allows us to eliminate the denominator. So that's what I wanted to do there. Okay, we'll rearrange this. We're going to have sine to the 4x equals 1. We want to get x by itself, so we're, well, first let's think about that. That's sine of x to the power of 4. And the best way to get rid of a power is by putting it to the power of a quarter there. Okay, again, we can do anything we want as long as we do it to both sides. And then here, 4 times a quarter is 1. So you're just going to be left with sine x here. And over here, you're doing the 4th root of 1. The 4th root of 1 is plus or minus 1. Okay, because minus 1 times minus 1 times minus 1 times minus 1 will also be positive 1. Okay, so it is both a positive and negative solution. And then what are the answers to this? When is sine of x positive or negative 1? That's going to be, so again, when I'm thinking about this, I'm going sine is the y value. Here it's positive 1, here it's negative 1. And so our solutions are pi on 2 and 3 pi on 2. Okay, we've got tan x equals cot of x, cotangent of x. So I'm going to go sine of x on cos of x equals, now there's 2 ways we can write cotangent of x, but because here we've got sine and cos, I'm going to write it in the sine and cos form over here as well, which is cos of x on sine of x. Okay, and then we're going to cross multiply the denominator. So I'm going to multiply both sides by sine x, and I'm going to multiply both sides by cos x. That's going to give us here sine squared of x equals cos squared of x. Okay, so from here, really you could look at your unit circle and try and find the solution. But I'm going to show you sort of the foolproof way where you can get to it even if you can't see the solution. So what we'll do is we'll move the cos squared x over to this side. So we're going to have sine squared of x take cos squared of x is 0. Now, so again, we could see the solution here, but let's go through a bit of a process to show exactly how we can generate it. So cos squared of x, remember our Pythagorean identity, sine squared x plus cos squared x is 1. So you can rearrange that in two other ways, but one of them is we could write cos squared of x is 1 take sine squared of x. Okay, so we're going to replace our cos squared x with that value there. So let's write the next step. We're going to have sine squared of x take 1 take cos squared of x. 1 take sine squared of x is 0. And then this, we can collect like terms here. That's going to be 2 sine squared of x take 1 is 0. And we're going to solve for sine of x. So move the 1 over. Divide both sides by 2. And then square root both sides. Plus or minus 1 over root 2. Okay, so plus or minus 1 on root 2. There's 4 locations where that occurs. And so the solutions are pi and 4, 3 pi and 4, 5 pi and 4, and 7 pi and 4. Okay, so you can, looking at the unit circle, you know the exact value that you're looking for. Up here, how could we generate the solution up here? Well, that's when we would look at our unit circle and we're going, I'm looking for all of the places where the y value squared is equal to the x value squared. Okay, and so that's the multiples of 45 degrees, isn't it? Here, the x value and the y value are equal to one another. Same in this location, only the x value is negative. Okay, but you can see if you square it, it's getting rid of all the negatives. So it's all the multiples of pi on 4 or 45 degrees. Okay, this one here, let's first move the 3 over. So we're going to have 2 sine squared x plus 5 sine x. Take 3 is 0. And then we're going to do that little trick. We've done it both in methods and we're doing it here. We're going to let a equal sine x. And then we're going to replace exactly what we have there with the letter a. So this is going to be 2a squared plus 5a, take 3 is 0. Alright, and it's much easier to solve a quadratic in this form. So let's use the cross product method. Multiples of 2a squared are going to be 2a and a, and then multiples of minus 3, we're going to have positive 3 and negative 1. Okay, and we can see when we cross multiply, we'll get 6a and minus a, which adds together to 5a. So this is our solution. We've got 2a take 1 times a plus 3 is 0. We're going to substitute sine x back in now that we've performed that factorisation. So we've got 2 sine x take 1 is 0. So we'll apply the null factor rule in that same step. Or sine of x plus 3 is 0. So this is sine of x is positive half. And that's going to generate the solutions pi on 6 and 5 pi on 6. And then over here we've got sine of x is minus 3. Okay? And this has no solutions. Can anyone tell me why?
Because the unit circle doesn't go up to 3.
Excellent. Yep, you're absolutely right. The highest possible value of any of the trig ratios, of sine or cos I should take, this can continue up further, is 1. Okay, so the highest possible value of sine is positive 1 and the lowest is negative 1. So minus 3 is beyond the scope of possible solutions. Alright, so that would be our answer for this one. So let's give a bit of 4i a go. It's good fun exercise.